Projectile motion is when you throw something towards the earth. It's a curved path because it is the intersection of the vertical and the horizontal components of the object when it is falling towards the ground. There are three types of projectile motion. One is when you throw something up in the air, another one is when you kick something at an angle at a certain speed, and another one is just when it is falling in free fall. Examples of projectile motion include a rocket ship when it is coming from space to determine where it's going to land in the ocean. And this was used in the Mercury project to determine where the spaceship would land after.
Go.
Projectile motion is also used to determine where the ball is going to go if you're playing soccer. So if you want to hit it into the net, the player has to use projectile motion to see at what angle she or he should kick the ball to make it into the net. When a person flies out of the windshield during a car accident, it is due to projectile motion, because when the car stops when it crashes against something, the person is still in motion and it continues going forward, and that is due to projectile motion. There are three equations that physicists use in order to solve problems with projectile motion, or to solve for velocity or acceleration or time. And they are v equals initial velocity plus the acceleration times t. The other one is x equals initial velocity times t plus 1/2 the acceleration times t squared. And the last one is v squared equals initial velocity squared plus 2 times acceleration times x.
So our first example is the problem with this given picture. So Alice throws a ball in this direction with an initial velocity of 10 meters a second. The elapsed time during this is 5 seconds, and we're going to calculate the horizontal distance traveled and then also the vertical velocity. So to use this problem, we're going to use vectors because it has two parts to it. So we're going to end up splitting it up into two sections. We're going to solve doing the horizontal and then the vertical on this side. So first we're going to go through and we're going to get all of our variables for the horizontal. So for this we have x, which would be we're looking for, and then we have velocity, which is 10 meters a second, and then we have time, so that's going to be 5 seconds, and then we're going to use x equals vt to solve for this. So x is going to equal 10 meters a second times time, which is 5 seconds, which gives us x equals 50 meters. And then we can put this in here. Then for vertical, we're going to solve, and we're going to put our variables in again. So the initial velocity is going to be 0, and then we're trying to find the velocity, so this is velocity y, so that's going to be a question mark. We have our horizontal displacement, which is 125. Then we have, what am I missing? Oh, we have our time again, which is 5 seconds. And we have our acceleration, which because it's being pulled down by gravity, it's going to be 9.8 meters a second. So then for this equation, we're going to use v equals v initial plus acceleration time. So it's going to be v equals v initial plus at. So v equals 0 plus 9.8 times 5 seconds, which ends up coming out to be 49. So Vy equals 49.
For this problem, we're going to talk about a cannonball being fired from the ground at an angle, and it has projectile motion where it's a parabola curve, and it comes back and it hits the ground in 4.10 seconds. And we know that the total distance it travels from its starting point to its end point is 73.2 meters. So we're going to try and find the horizontal velocity. For that, we're going to use x equals vt, and then plug in our values. So we have 73.2 equals our horizontal velocity times time. And so when we solve this, we find that our velocity equals 17.9 meters per second. Now we're going to find what the vertical displacement was at the midpoint, or halfway through the projectile, and the highest point that the cannonball goes into the air. So that's going to be our vertical displacement. We're going to use the second equation for that. So our vertical displacement, or how high it goes, equals our starting velocity, which was 0, times time, plus 1/2 acceleration times time squared. So when you solve this out, you're going to get the maximum displacement to be 20.58 meters high. Because velocity is a vector quantity, that means we have to split it up into its two parts to find the total. So we already know the horizontal velocity, and if we want to try and find the vertical, we can do that. But first, we have to make sure that we're only looking at the first part of this path, because when the vertical velocity equals 0 at the midpoint, from there down it's just free fall. So we're going to only look at the first part when it goes from start all the way to its highest point. To solve this, we're going to use the first equation. We're going to say that the velocity equals the starting velocity at 0 plus the acceleration due to gravity times half of the time. And then when we solve this, we're going to find that the velocity equals 20.09. And now, if we wanted to find this angle at which the cannonball is fired, let's call it theta, we could use trig to figure that out, so because we have all of the components of the vector. So we could say arc sine, which means the angle whose sine equals, and it would be opposite over hypotenuse equals theta. And then when we do this out, we realize that theta equals 48.24 degrees. And that's the angle at which this cannonball was fired.